So going back to my previous example where I was throwing a marble, there is one effect that we did not mention, but that is very, very, very important. Now, as you can see, I only have one hand, and the other hand is turned into a timer. Anyway, so when I release this thing, I'm going to get a spare of time, indeed. What happens if I change the height? So what happens if I get lower or if I get higher? What will happen to the times? Well, of course, if I get higher, then the time will get higher. If I get lower, the time will get lower. It's not going to be a straight line because of acceleration. But that's not what I'm really interested in. What I'm really interested in is that as I get lower, you'll see that the time that I measure does not go to zero, but sort of ends up at a certain limit. So this does something like this. It should go to zero, but it doesn't quite go to zero because there's a minimum time here that I always get when I measure. You may be wondering, well, how's that possible? Well, that's simply possible because that's the way I'm measuring things. I start the timer when I see this, when I release this, and this is roughly immediate. But then it takes a while for me to see the marble fall and then press this thing. So even if this thing falls instantaneously, I would still measure a time between the time that I drop it and the time that it hits the floor. So the problem is here is really in my method of measuring. Because I have a certain reaction time that goes from the time that I see the marble until the time that I press the button, every one of my measurements here are going to be bigger than they should be. This type of error is not random at all. This should be here. But it's over here, and these two curves, if I could draw, they would look exactly the same, but just a little shifted. What's happening is that because of the way that I'm measuring things, I am systematically overestimating one of the quantities. That's why this thing is called systematic error. And as opposed to random error, this is really, really easy to get rid of. One way to get rid of it is simply to change your measuring system, not necessarily the device, just the way you're doing things, taking this into account and then simply making this disappear. But you don't even have to do this. You can keep your systematic error all the way, simply be aware of it, and then once you have this thing, you're like, oh look, this time here has to be my reaction time. I'm just going to shift all the curve by a little bit and then done. Systematic error is gone. So once you are aware that you have a certain systematic error, you can just then treat your data, modify your data until the systematic error is removed, even if you still even if there's still error in the way that you measure. So as I said, contrary to random error, it's not a good error to have, but if you find out that there's systematic error much after you've done your experiment, there's always a workaround, which is simply identifying it and then shifting your data accordingly. Although it's always better to just prevent it and think about it before you start doing a measurement. Will I introduce some systematic error if I do things this way? And if the answer is yes, can I do them in a different way so that there's no systematic error? One more thing that I need to say about systematic error is that it's normally due to instrument calibration, especially if you're using electronic devices, such like as a voltmeter or a force meter. You'll see that, for example, when you have a force meter and you're not measuring anything, the force meter still has a reading that says 0.2 newtons. And you're like, well, but how is this possible if you're not measuring anything? And that's because you haven't calibrated the device. So you need to make sure that you calibrate your devices every time you use them. Some devices have a tendency to uncalibrate themselves all the time. So you need to watch out for that in case you need to recalibrate at some time during the experiment. And you will easily see that there's a calibration mistake when you see your graphs. But again, try to avoid that simply by calibrating your instruments before you start to do the experiment.